Good morning, everybody, and welcome to our third webinar of the day if you've been with us all morning. So we'll just give folks a moment to join online. All right, well, it's 11:01, so we will get started. So good morning, everybody, and welcome to our webinar today. And the topic is it's an update on facilities decommissioning for major projects at the Chalk River Laboratory site. My name is Rachel Chenette. I'm a communications officer here at CNL. So first, I would like to acknowledge that the CRL site is located on the unceded and unsurrendered territory of the Algonquin and Anishinaabe people. As an organization, CNL recognizes and appreciates all of the Indigenous people's connection to these places. CNL also recognizes the contribution that First Nation, Métis, Inuit, and other Indigenous peoples have made both in shaping and strengthening the communities where these projects are situated and to this country as a whole. So today's webinar will include a presentation and then we'll open the floor for Q&A. I'll go over a few housekeeping details before I introduce Kaylee, who will kick off the presentation. So there is simultaneous interpretation available for the webinar. You can access the session in either French or English through the globe icon on the bottom bar of your Zoom. Select the language you would like to hear, and please note there is a slight lag in the translation. Today's session is planned for about 1 hour, 45 minutes. We anticipate, 45 minutes to an hour, depending on how many questions we have. We anticipate the presentation will take around 30 minutes. So please use the Q&A icon to submit your questions at any point during the presentation. You don't have to wait for the end, and we'll respond to all questions once the presentation is done. And anyone that we cannot get to during the webinar or that needs additional details, we will follow up in writing to everyone who has joined us today. Please note that we will be recording these sessions and posting them on our YouTube channel afterwards. We usually get them up about a week after the webinar. If you'd have any issues or would like to chat further outside of the webinar, please get in touch with us at ermstakeholder@cnl.ca. Our team will be watching the inbox and we'll get you the answers that you need. The final thing to note is that we are looking to evaluate our webinars and keep bringing you topics that are of interest to you. So following the webinar today, you will receive an email with a link to complete a short 10-question survey. We would really appreciate it if you would take the time to share your thoughts on our webinars. So now I'll introduce our presenter, Kaylee, Director of Facilities Decommissioning and Environmental Remediation here at Chalk River. Kaylee, do you want to go ahead and introduce yourself and we'll continue on with the webinar?
Yeah, absolutely. Thank you, Rachel. So my name is Kaylee Greener. I'm the Director of Facilities Decommissioning and Environmental Remediation, and that has essentially the scope of decommissioning and remediation work at the Chalk River site. So for the update today, I'm bringing you an update on our 3 major decommissioning projects, which really is just a term to describe projects of really significant scope, cost, efforts that we put into these projects. So this is the Building 250 decommissioning project, the Building 200 series decommissioning project, and then the Building 100 NRX reactor decommissioning project. It is important to note that our teams are actively working across upwards of 50 different facilities at any one time at the Chalk River site. And this presentation is again focusing on the 3 major projects that we have currently underway. So to start with, I'm going to look back at highlights from the last year in Building 250. So as a reminder, for those of you who haven't heard of this project in a while, or for those who are new to it, Building 250 is a former chemical engineering laboratory. It was constructed in the late 40s and into the 1950s. It's a 5-story facility, 3 distinct towers, south, central, and north. And we began decommissioning work on this facility back in 2020. So in the last year, we had a big focus on fume hood removals. So fume hoods are devices cabinets where experimental work can take place in a safe environment where researchers can put various chemicals and substances that require full ventilation to protect the worker from manipulating those chemicals. They're contaminated both with conventional hazards like chemicals from experiments, but also radiological hazards. We've progressed our removal of fume hoods in the south tower of Building 250 and have removed all of them. So we've removed 30 fume hoods from the building as of last year, and actually progressing into this year, we've removed another 10 for a total of 40 removed to date. In the North Tower, we've shifted to performing characterization efforts on these fume hoods, and that's largely where we're now focusing in on some of our fume hood removals. And then we've also done characterization work in the active ventilation systems that these fume hoods were connected to, and ultimately were filtered and then ventilated out to the environment. Continuing in the South Tower, we also put a big focus on active drain removals. So the active drains was a system of piping that collected liquids being discharged from the fume hoods that would be collected and then connected into the site active liquid drain system. As in the South Tower, we successfully completed the removal of the entirety of the active drain system. So there's no more drains located within the South Tower. And we've also successfully isolated and air gapped the connection into the site infrastructure system for the active drains. So with this work, we've removed over 200 feet of the larger diameter 3-inch piping, and also hundreds of feet of the branch lines that connected into the various different fume hoods throughout that tower. Over in the North Tower, we've progressed the hot cells to a demolition-ready status. So hot cells are shielded structures where work on high-dose radiological components can be undertaken. So staff can work on those components through the use of remote manipulators while being protected by the shielding of the thick concrete walls of these cells. Building 250 has 2 hot cells that happen to be on the 5th floor, which makes access a little bit of a challenge. Previous to the last year, the teams had removed all of the fixed and loose components, so the manipulators, components that were inside the cells, transfer ports, etc. But then over the course of the last year, the teams conducted extensive remediation, culminating with concrete scabbling to reduce the contamination and the dose rates to an acceptable level to support the eventual demolition of the hot cells. So we now have the cells in a state where they've been remediated, they've been stabilized. We have some temporary ventilation in place just to ensure we still have a ventilation draw, but these cells are now effectively ready for when CNL has a low-level waste disposal facility available, and these can be demolished at that point. Looking ahead into the next year for Building 250, which we're in progress with now, key focus for us in the South and Central Towers is to progress those 2 portions of the building to a demolition-ready status. So to do that, there's 2 real large remaining activities that we need to accomplish. The first relates to the ventilation systems in particularly the South Tower. So we have identified a somewhat unique hazard called perchlorate salts that is deposited in some of our ventilation systems, and this can be a shock flash explosive type substance when disturbed. So we are working with both internally within CNL and some experienced support coming from the supply chain to develop a plan to perform the remediation of those ventilation systems, which will then allow us to complete the removal. And then we're also doing the final characterization and remediation efforts in the South and Central Towers. So our goal is for the Central Tower of Building 250 to be deemed demolition ready in March of 2025. And then the South Tower, which does have the perchlorate contaminated ventilation systems, to be demolition ready shortly thereafter in September of 2025. Moving over to the North Tower, we're continuing with a focus on fume hood removals at the moment and performing isolations and air gaps on various services in the facility. We are now shifting our crews to perform the removal of the active drain systems, which I talked about in the South Tower. We're now starting to perform those removals in the north. And we're also progressing with a surgical demolition design for this facility. So what that means is we believe that we can have the central and south tower deemed as waste that can be disposed of without a low-level disposal facility on our site. However, the north tower, with the history of operations and some operational accidents in the early years of service, we will not be able to achieve that objective. So we do need the north tower to remain until we have a suitable location for a low-level waste disposal. So we do need to come up with a design where we can safely separate the central tower of this facility from the north, so we can proceed with the eventual demolition of the south and central portions of the building, while the north tower will remain compliantly and safely in place until we are able to progress with the demolition of that facility. Okay, moving on to the next major project that we have underway, which is the Building 200 series. So this was a collection of 3 buildings that supported the operations of the NRX reactor. So Building 204 was the rod bay facilities that received the irradiated fuel coming from the NRX reactor. We had Building 200, which supported work related to thorium from the fuel, and then Building 220, which supported work related to plutonium from the fuel coming from the NRX reactor. So for Building 200A, our focus of last year was the culmination of efforts over a number of years to bring this facility to a demolition-ready status. So the entirety of the interiors of these facilities of Building 200A have now been remediated from a radiological perspective. We have done extensive concrete removals, system removals, remediation efforts on the concrete, on the wood, completed all of the asbestos removals inside of those facilities, and we have achieved at the end of the year a demolition-ready status for these facilities. These facilities will require a low-level waste disposal facility to receive the waste ultimately from demolition, so we will not be proceeding with demolition at this time. However, we've removed the hazards to get it to that point, and we're now going to be carrying on with other enabler activities to support the eventual demolition of this facility. And a pretty cool item to note. So we've deployed a first-of-a-kind technology within this facility to support the remediation efforts. Across the 200 series, we have about 12,000 square meters of concrete to remediate. In Building 200A, there was about 3,000 meters, which is a significant amount from a hand grinder or other small-scale remediation type of technology. So we've developed, working with the vendor in the supply chain, a remotely operated wall scouring system that can be moved to walls and adhered with vacuum suction. And then it is operated from a different part of the facility with reduced dose rates and a safer environment. So we've deployed this machine extensively throughout the remediation of these facilities to achieve that 3,000 meters of remediation completed. And by doing that, it's also allowed us to downzone most of the portions of this facility from a zone 4 to a zone 2 environment. So staff can now access areas of this facility with just simple PPE without having to wear full air suits and Tyvek suits. So it's a great improvement from a safety perspective, from a cost perspective, as we monitor this facility until we do get to a point of demolition. Over in Building 204, another really impressive piece of work that I want to share. The teams completed the removal of all the Bowser room systems. So the Bowser room was the filtration room that contained all the pumps, the tanks, the filters, the piping that filtered the rod bay water from Building 204. This was a highly contaminated room. It was also in a very inaccessible location in the building, being in the basement. So the teams came up with a very innovative solution to access this room directly through the basement walls. You can see from the photo on the top left, which is an animation of the work. They made an excavation next to the building, placed some access containers that we custom designed for this job, and then they cored holes through to the basement of this facility to access this room, which you can see in the top right image. Then, recognizing the contamination levels within the facility, we opted to go with a fully remote approach to complete the demolition of all the systems in this room. So the teams deployed our Brock robots into this room, which were operated from an adjacent space that was air conditioned, no dose rates, a very safe environment for the staff to work. And in doing so, they successfully completed the removal and the packaging of all of the components from within that facility to be shipped to our on-site waste storage areas. Throughout this job, the teams generated about 6,000 kilograms of intermediate level waste and 3,000 kilograms of low level waste. And most importantly, by using the robotic technologies, we avoided about 5.6 rem of dose to staff had we done this in a more manual effort. Some other great work within Building 204. So we've recognized that we need to perform some additional overhead work in these facilities to characterize and remove systems in the upper spaces of Building 204. However, the dose rates coming out of the former rod bays are too significant to have staff do that work. So the teams deployed again some new technology on our site where we used our Brock robots to go inside of the bays, and we sprayed a special polymer adhesive to the walls with the objective of that to both stabilize the contamination, but also to provide an impermeable barrier where we can now put gravel inside of these bays to provide a safe working surface for the overhead work, but also, and even more importantly, to provide the shielding that we need for workers to be doing that work without getting unnecessary dose. And looking into what we have next year, so we've completed spraying of one of the bays within 204, but we're going to continue doing that throughout the remainder of the year and the other fuel bays within 204. And we are going to start filling the bays that require the shielding. We're going to start filling those with gravel. We're also going to really progress with our systems characterization once we have that appropriate shielding and working area in place. We're also going to complete the external asbestos abatement on Building 204, and all of that is to work towards our goal of having that facility demolition ready. And then in Building 220, which I didn't talk about much from the last year, the teams will be doing contaminated system removals from the basement rooms in Building 220. Moving over to NRX, Building 100. So this was the National Research Experimental Reactor that operated from 1948 through to 1992. The focus of this year was really characterization-related efforts in the reactor, and that's to help us inform what our reactor segmentation strategy and waste packaging is going to need to be like. So working internally within our own mechanical equipment development group and our decommissioning teams, we developed some unique tooling that we could use to obtain samples from inside the reactor. So we had two campaigns this year, one of which we cored through the entirety of the bioshield, which is the concrete shield that surrounds the reactor. So we could obtain samples of the graphite reflector that surrounds the reactor, which is in the middle photo there. And then we also used another set of tooling to access two of our reactor positions to go down into the center of the reactor and take swipes and scrape samples to help us understand activity levels and dose rates so we can proceed with further planning on eventual segmentation of the reactor. The X9 pit is a large area off the side of the reactor that was supposed to be used for another experimental system when the reactor was operating. However, that project was abandoned, and this pit essentially turned into a storage area for various NRX reactor tooling, components, and equipment. So the NRX team put full effort into this over the last year to clean out this pit. They characterized all of the equipment and tooling that was stored in here, packaged in size reduced for disposal, performed remediation throughout the pit as required. And so effectively now we've made available quite a bit of real estate inside the building to support some of the ongoing decommissioning activities now and over the next decade or so as we progress with the decommissioning of NRX. On the line of characterization, we had to make some extensive modifications to the building ventilation system in order to support some of the characterization work we have upcoming. The team has accessed the rod trench pulley room for the first time in decades to obtain characterization data from that room. And the rod trench pulley room was effectively the transition zone from where the fueling machine from the NRX reactor would hand off the fuel to the trolleys that brought it into the 204 rod bay facility. And then we've also progressed with characterization and some removals of some ancillary experimental systems to the reactor, such as the biological test facility. And looking at what we have upcoming for the next year, we're going to do removals of components within the rod trench pulley room. We're going to continue with characterization efforts inside the reactor with some additional reactor positions planned for sampling. And we're going to continue with the removal of legacy systems and services. So the NRX reactor building was completely refed with a new electrical system about a year and a half ago. And there'll be a focus this year on removing the legacy electrical cabinets, components, control cabinets, wiring, etc., just to ensure we have full understanding of the configuration of the facility, and again, to free up some of the critical real estate inside the building that we need to progress. Okay, so that was our short update on what we have on our 3 major cleanup projects within the decommissioning portfolio. And again, as I mentioned at the start, we do have crews deployed throughout a number of other facilities, but the focus here was on our 3 big projects that we have ongoing. So with that, I guess we turn over to questions.
Great, thanks, Kaylee. Lots of good information in that update. I always learn something new listening to facility decommissioning updates from your team. So we do have a couple of questions coming in, so we'll get started. This is great. So is CNL self-performing the decommissioning work in Building 250?
CNL is self-performing the vast majority of work in our decommissioning portfolio, including Building 250. But we do draw on contractor support where needed. So in the specific case of Building 250, we've brought on some contractor support over the last few years to help us with our asbestos abatement campaigns. As you can imagine, a building the size of 250 in the era it was constructed, there are significant amounts of asbestos throughout the building. And as I mentioned with the perchlorate challenge that we're working through, that is a new hazard to us from a perspective of characterization and remediation. So we are working with a contractor who has some experience in this area to help us work through both developing the technology and executing the actual work to do the fulsome characterization and remediation inside of our ventilation systems.
Great, thanks, Kaylee. And before we continue, because some of these questions might get a little technical, if there are any that we can't answer right away, and I don't want to put you too much on the spot, Kaylee, recognizing that it's just you on the webinar today, we can always follow up in writing with folks. So we'll continue on. So for the Building 250 North Tower, did you perform a chemical or water surface decontamination before scabbling the contaminated concrete? And I don't know if I pronounced that right.
Yes, we did perform a chemical decontamination using a gel substance in the hot cells. We did quite a number of rounds of that decontamination before moving on to the concrete scabbling.
Great. And will B250 be done with open air demolition?
That is our objective, and we are conducting extensive characterization efforts to ensure that we can meet that objective. We've built air dispersion models that reflect the layout of the site and unique geography, particularly with the large sloping hill coming down from the hillside leading towards the building and then towards the rest of site. So we do know the criteria that we need to clean the building to effectively to perform open air demolition. And that's what's really driving a lot of the extensive remediation efforts that we're taking in that facility.
Great. Thanks. So, Kaylee, what is the most effective method for contaminated demo and decontamination that you've found? Did you heat the demoed concrete? How large were the concrete chunks after pulverizing the concrete?
So important to note from the concrete perspective, given the weight and volume that contaminated concrete occupies, we only do generally surface type remediation on concrete, and we recognize where we need to stabilize and wait until we can generate some of the larger volumes of concrete to fully complete the work. But for some of the examples that we've shown here, like the scabbler, it makes really quite a fine dust that we store in drums. And similar to the concrete that I presume it's being referred to in the photo that had the Brock robot, pulverizing a concrete floor of one of the working spaces, that concrete is also put into 55-gallon drums.
Great, thanks. A couple more coming in here. So, what is or are the final end states for facilities subject to decommissioning and or demolition and decommissioning? So, final end states.
So the final end states are part of our overview decommissioning plan for the site. So the final end states aren't fully established at this point in time. So we are working to interim end states to effectively reduce the liability, reduce the risk, where we can bring the buildings down to ground level. But it's important to recognize that a site with the legacy that Chalk River has, there's a significant amount of below grade infrastructure that would need to be dealt with and managed as well to fully support an ultimate end state, and that needs to all be really coordinated with our final environmental remediation efforts that work through the site, both removing any below grade contaminants, but also the below grade infrastructure at the same time.
Thank you. Okay. So, what does the big picture for decommissioning schedule look like for the Chalk River site?
Right, from a big picture perspective, we are effectively going to be operating with the crew sizes that we run with now well into the 2040s. There's still quite a number of some fairly high hazard facilities that will be transitioning over to decommissioning as some of the new construction at Chalk River comes online, such as the Advanced Nuclear Materials Research Center. So we will be another couple of decades at our current pace and current resourcing levels before we need to start just ensuring that we have the right size of workforce as the number of facilities starts to reduce on the site for decommissioning. But ultimately, our team will be here until the very end, until the last of the new builds are shut down and decommissioned, which would be at least half a century, if not more, from now.
Yeah, and Kaylee, maybe I could drop a link into the chat here for everybody that's online, because we do have a overview decommissioning and cleanup plan for the Chalk River site that provides a general summary of the proposed approach to decommissioning and environmental remediation. So I can include that for
Sure.
everybody. We've also done a couple of webinars on the overview decommissioning cleanup plan, ODCP, because we love our acronyms at CNL here. So you can always go back on our YouTube page and check those out. So our final question here is, are any of these projects subject to the Impact Assessment Act?
So at this point, all of our decommissioning projects are not disturbing new areas on the Chalk River site, and the work we conduct is all within the existing site licenses. We're not changing the license, we're simply removing facilities from the license. So at this point, our removal projects have not been subject to the Act.
Great, thanks, Kaylee. So I had a question as a bit of a follow-up from our nuclear power demonstration closure project webinar that we had just before this one, and I thought it was a nice question that would tie in. So there was a question about exploration of alternative decommissioning plans using robotics and advanced technologies. So I know your team does a lot of great work innovating the process. So I was wondering maybe if you could just spend a little bit of time talking about kind of different techniques and utilizing really interesting technology.
Sure. So really, when we opt to deploy technology to accomplish some of our tasks, the goal of that is not necessarily coming from a cost reduction perspective or a schedule reduction perspective. The driver when we deploy technology is really from a worker safety standpoint, that it really does prove to be far safer for our teams if we can do some of this work using remote technology. Ultimately, if we can remove staff from the work front, that significantly reduces injury rates, significantly reduces dose rates and potential contamination. So we work closely with other elements on our site as well, like our innovations team within the decommissioning organization and the mechanical equipment development group, to see where we can develop new tools or enhance some of the existing robotics that we have for specific tasks. So that's always something that we have at the forefront when we're moving forward with these jobs. And if I reference the Bowser Room job, which I shared here on building 204, which was really exciting how that was approached, just a total different way of thinking, from making new access ports into the building and then ultimately using the Brocs. That was not cheaper and it was not faster. In fact, that took us about a year longer to do it that method, purely with all the upfront planning that was required and the mock-ups required to ensure the robotics worked. We had the right tool heads in place. But from the safety perspective, we had zero events when that work was being executed. And when you think of the volume of waste removed, I think it was between the low level and intermediate level was over 11,000 kilograms. So 11 tons of largely metal waste. If that was being done by hand, the risk of someone having a pinch, a cut, a strain, handling those materials certainly would have been prevalent. And from the dose perspective, 5.5 rem of dose savings is not inconsequential to avoid that dose to our staff. So those are really the factors that drive our deployment and use of technology over anything else.
Thanks, Kaylee. Really interesting stuff, and I think it might make a nice future webinar topic. So, okay, we'll just wait a moment. Oh, perfect. A couple more questions came in. Perfect. So you alluded to the need for a low-level waste facility. What is the plan for that, and how would that necessary facility be different from existing low-level waste facilities?
I probably wouldn't be the best to answer. I would be an end user of such a facility, but maybe Rachel, that's the question you can take on from some of your involvement within NSDF.
Yeah, and I believe the facility that you were talking about was NSDF,
Yeah,
Kaylee, when you were talking about the low level waste that would meet the acceptance criteria for the
yeah.
proposed near surface disposal facility. So that is the current proposal from CNL for that. Margot, did you have anything else you wanted to jump in and say on NSDF?
Sure, thanks, Rachel. So as some of the listeners may be familiar today, CNL does have a near surface disposal facility for low level waste proposed. And in January of this year, the federal nuclear regulator, the Canadian Nuclear Safety Commission, did announce that they had granted a license amendment for Chalk River Laboratories to enable the construction of such a facility. However, as of February, CNL did become aware that there were applications for a judicial review for this facility, for the decision that the CNSC had made for the construction of this facility. So that process is underway now. Yeah, so stay tuned from CNL for more on the process for that facility. But right now, that's what we can say about that. And I'll put a link in the chat to some more information about the NSDF.
Perfect. Thanks, Margot. And I did notice you dropped in the overview decommissioning cleanup plan link there as well. And just for everybody on the line, Margot is a senior communications officer on our team. I did not introduce her at the beginning. My apologies. Okay, last question, Kaylee, that's come in so far. So how does FD select their decommissioning strategies? Do they complete optioneering exercises for each facility on the best way to complete decommissioning activities? So this sounds like somebody that might have worked at CNL before.
So effectively, we do that through the development of our detailed decommissioning plans, which apply for our class 1 facilities, and then building removal plans for our lesser class facilities. So we do review the overall scope of the project and effectively come up with an overarching strategy that considers some of the options available to us. However, when we then move into detailed execution on very specific elements of the job, that's where we also then conduct much smaller versions of optioneering to determine what the best path forward would be. And that would be where some of our technology deployment comes into play when we review various options for completing specific work packages.
Great, thanks, Kaylee. So there's no more questions in our queue here. So I'm going to launch a poll for everybody. So we would like to know how frequently you would like updates on facilities decommissioning at Chalk River Laboratories. So we do these updates with Kaylee and members of his team less frequently than we do for some of our other projects. You folks online would probably be familiar with all of our NPD, Whiteshell, and SDF related webinars. So we're interested to know how many times a year you'd like an update from Kaylee and his team. So we'll leave that poll open for a moment so folks can get their answers in, and then we'll begin to wrap up our webinar for today. So a couple of reminders, but first a big thank you to everybody for joining us today. And if you joined us for more than one webinar, thank you for spending so much of your time with us on what's a beautiful morning so far here. I'm sitting in Eganville and it's absolutely gorgeous out. So we'll send out links to the recordings once they're posted on our YouTube. The French and English will be available. It's usually about a week after the webinar. And we'll also be sending out the post-webinar survey that I mentioned at the beginning. So if you could please take some time to complete that survey, it'll help us improve our webinars and provide or come up with topics that are of interest to everybody who attends them. And remember, if you have any questions or you want to get in touch with us about facilities decommissioning or any of our projects at Chalk River or the other sites, you can email us at ermstakeholder@cnl.ca. So thanks very much for attending, folks. Again, we really appreciate it. And thank you, Kaylee, for joining us for this webinar.
Welcome, happy to.
So with that, we can wrap the webinar up. Thanks, Global, for your support.